Yeah, children. I'm sure you have tried the first question. Anyone wants to share the answer? What is the surface area of the bigger sphere? Okay, so the question says two spheres have their volumes in the ratio of 1728 is to 2197. So volume of, you can see the ratio. The first number is smaller than the second number. In the ratio, the first number is smaller than the second number. That means the volume of the first sphere is less than the volume of the second sphere. So the first sphere is smaller in size when compared to the second sphere. You can make out from the ratio. See the ratio? The first number is smaller than the second number, which says that the first sphere is smaller in size, has a smaller volume when compared to the second sphere. So two spheres have their volumes in the ratio. These are not the volumes. The volumes are in this ratio. These are not the volumes. Okay, so this is the ratio of their volumes. If the surface area of the smallest sphere is 3024 centimeters square, find the surface area of the bigger sphere. So we know that the formula to find the volume of a sphere is 4/3 pi r cubed. So what are we given? We are given, don't write now. I have the answer on the next slide. I'll present that. Please listen. So 4/3 pi r cubed by 4/3 pi r cubed, right? Because both are spheres. The ratio of their volumes is 1728 by 2197. So 4/3 in the numerator and denominator gets cancelled. So with pi gets cancelled. So we have r by r, the whole cubed is equal to what is, what's the cube root of 1728? Or how can you express 1728 by 2197 as a perfect cube? Yeah, that you have to tell
12
me.
by 12
Yeah,
by 13.
12 by 13. 12 by 13. So 12 into 12 into 12 is 1728. 13 into 13 into 13 is 2197. Okay, so we have r by r, the whole cubed is equal to 12 by 13, the whole cubed. So r by r, the ratio of their radii. The ratio of their radii is 12 by 13. Now, if the surface area of the smallest sphere is 3024. So let's just write the ratio of the surface area. So we have 4 pi r square by 4 pi r square, right? Because surface area of a sphere, 4 pi r square. So 4 pi small r square by 4 pi capital R square is equal to, what are we given? We are given the surface area of the smaller sphere. So let's write that in the numerator, right? Because this is the numerator is the numerator here on the left hand side is the formula to find the surface area of the smaller sphere, and the surface area is 3024. So 4 pi r square represents the surface area of the smaller sphere. So we write 3024 in the numerator here over, or we have to find the surface area of the bigger sphere. So you can just call it as x or whatever. See, this is one part. We found the ratio of their radii. That's one part. Now we'll write the ratio of their surface areas. 4 pi small r square by 4 pi capital R square. The ratio of their surface areas is equal to, we know the surface area of the smaller sphere, 3024. Write that in the numerator. You should not write that in the denominator because the numerator here is about the smaller sphere. So the surface area of the smaller sphere should be written in the numerator on the other side. By surface area of the bigger sphere is what we have to find. So we'll take it as x. So again, cancels. 4 pi in the numerator and denominator. So we have r by r, the whole square, is equal to 3024 over x. X is the surface area of the bigger sphere. See, here we've written the surface area of the smaller sphere, and x is the surface area of the bigger sphere. So when you work this, meaning when you solve this equation for x, that's the surface area of the bigger sphere. So r by r is 12 by 13. 12 by 13, the whole square is equal to 3024 over x. Now work this and you can find the value of x. I'll just check if I've done it in the same way. The next slide. Yeah. Yes, children. You can start writing from this side itself. Please start working. Yeah. You can start like this. Let the radius of the small sphere be r and big sphere be small r and capital R. Please work. Cross multiply and find the value of x. Yeah, what's the value of x? Okay, children, use the emoji. Raise your hand. Akshada, Anirudhan, Swati, Niveda, Bhavishya, Keshav, Blessy, Haripranav, Kamalika, Jayavashini, Anugraha, Keshav, Srivatsan, Mohammed, Ritsa, Sabarna and Sadhna. Please tell me the value of x, children. You're still working?
And value of
Get to
x
find?
is 3549.
So the surface area of the bigger sphere is 3549 centimeter square. Finish working?
No, ma'am.
Okay, yeah. Write the answer in a sentence. The surface area of the bigger sphere is 3549 centimeter square. After getting the value of x, please write the answer in a sentence. All right. Shall we go to the next one? Okay. Yeah. A spherical copper shell, a spherical sphere, copper shell. Copper is a material like iron, copper. So a spherical copper shell of external diameter 18 centimeters is melted and recasted into a solid cone of base radius 14 centimeters and height 4.3 by 7 centimeters. Find the inner diameter of the shell. So this is a spherical shell where we have two radii or diameters. We have for this shell, we have the inner radius or the inner diameter, outer radius, outer diameter, which means it's something like a coconut, right? If imagine a coconut which is, in the shape of a perfect sphere, which is perfectly spherical, a coconut, which is a perfect sphere. So there is that empty space inside, right? The middle of the coconut is empty inside, a full coconut. So the sphere in the question is like the coconut. The sphere in this question is like the coconut. So when you take up this, when you look at the coconut, 1 second, children. Yeah, thank you. So when we, take this coconut as an example, you can see it has an inner radius that is from the center to the inner wall, the white inner wall. So from the center of the sphere to the inner wall, the white wall, okay, will be the inner radius. And from the same center, from the center of the sphere to the outer wall, that is the brown shell, outer wall, will be the outer radius. So internal radius is from the center of the sphere to the inner wall, which is that white edible portion, you know, the coconut we eat. So that edible portion. So from the center of the sphere to that edible wall, you know, that is the inner radius. And from the same center to the outer shell, the brown wall, which is not edible, right? So to that is the outer radius. So it's empty in the middle. The sphere is empty in the middle. So there are some chocolates also like that, no? Spherical chocolates, hollow in the middle. Okay. So the formula to find the volume of such a sphere, the formula to find the volume of such a sphere is external volume minus internal volume. Whenever a solid is like, you know, empty in the middle, but has two radius, the volume is always external volume minus internal volume. The volume of such a solid will be external volume minus internal volume. That is when it is not a, now in this case, it's not a solid sphere. This one is not a solid sphere. It has two radius. So in such a case, the volume of the solid will be, the volume of the spherical copper shell here will be, so sorry children. Yeah, in such cases, the volume of the solid will be external volume minus internal volume. So here it will be 4 by 3 pi capital R cubed minus 4 by 3 pi small r cubed, where you can take 4 by 3 pi common, r cubed minus r cubed. So this is the formula. This is the expression you have to use to find the volume of this, copper shell, spherical copper shell. Now the other solid in the question is cone. Cone. Now let's see what values you need for the sphere and the cone in this question. So you see in this formula, for the sphere, we have the external radius capital R and the internal radius small r. And for the cone, volume is given by 1 by 3 pi r square h. Let me say r1 because we've already used r here. So r1 square h. So again, we have the radius and height of the cone. And for the cone, we know the radius and the height. For the cone, we know the radius and the height. And so both are known. For the cone, both radius and height known, given in the question. For the spherical shell, we know the internal radius, this one, because, sorry, we have to find, right? Okay, the external diameter is given. So we know the external radius. We know the external radius, the outer radius we know because the outer diameter is given in the question. So we have to find so this is given. This is given. So we'll have to find this. So as I've told you earlier, you have to read the question and frame the equation in words. Read the question and frame the equation in words. So in words, the equation will be volume of the spherical shell is equal to the volume of the solid cone. Because this shell is melted and all the material which was in the shell, the copper material which was in the shell, so it's melted and the entire thing goes to form the cone. There is no wastage in the process because nothing is given to us in the question. So we assume that there is no wastage in the conversion process. So it was a spherical shell. Now it is a cone. All the material that was in the shell, the spherical shell, all that material is now in the cone. So the equation is volume of the spherical shell is equal to volume of the cone or solid cone. Because whenever one solid is melted and converted, recast into another solid, their volumes will be the same. Their volumes will be the same, assuming that there is no wastage in the conversion process. So here, now write the formula. Volume of the spherical shell, 4/3 pi capital R cubed minus small r cubed is equal to cone formula, volume formula 1/3 pi R1 square H. So easily you can cancel 3 and 3 on both the sides. Pi gets cancelled on both the sides. So 4, open bracket, external radius, 18. So external, no, what did I say? External diameter, 18. So external radius, 9. So 9 cubed minus internal diameter. We have to find, that means internal radius we don't know. So this is R cube is equal to radius of the cone, 14. So 14 into 14 into height of the cone. So 4, 3/7. So that's 28, 31/7 it is. And yeah, all the values are in centimeter. All the values are in centimeter. So now we have to solve this equation and find the value of R and double that to find the internal diameter of the shell. Yeah, please solve this equation. Write the question. Done, children? Okay, I assume that all of you finished. Next one. Just check if we have already done this question. I remember taking up a similar question, or I don't know if it's the same question in the last class, one of the classes on this chapter. I don't know why today children, nobody's responding. Please check and let me know. Vivek, this is the third session on.
No, ma'am.
Okay, this is the third session on volumes and surface areas.
Ma'am, but there is a similar question related to
Like
this question.
Oh, very good. Thanks, Aniruddhan. Yeah. Okay. Very good. So we'll do this. A vessel is in the form of an inverted cone. Okay. Its height is 11 centimeters and radius 2.5 centimeters. Good. It's filled with water up to the rim. So it's completely filled with water. When some spherical, so that's the shape of the solid sphere. When some spherical lead shots, each of radius. So for the sphere, we know the radius. What else we need? For sphere, you only need this value, radius. That's a given. So when some, but how many spheres is not given? When some spherical lead shots. So how many spherical lead shots is not given? So when some spherical lead shots, each of radius 0.25 centimeters are dropped into the vessel, what happens? 2/5 of the volume of water flows out. Find the number of lead shots dropped into the vessel. So the two solids in the question are, okay, the cone is not a solid cone here. It is a hollow cone because it's filled with water. Okay, so the one is, it's not a solid cone, but I'll just say solid, okay? So the two solids mentioned in the question are cone and sphere. Cone and sphere. For the cone, we need two things, radius and height, given. And for the sphere, we need only one thing, which is the radius, given. So good. For cone, we have radius and height, and for the sphere, we have the radius. All right. Then what is it we have to find? We'll have to find the number of, spherical lead shots dropped into the vessel. Okay. So you should always read the question, understand, and construct the equation in words. When you do that, you can convert that equation which you convert, that equation which you construct in words should then be converted to a mathematical equation using formulae. Okay, so tell me, what is that equation in words you can write for this situation? Yeah, you have to tell me. Okay. So the volume of all the spherical lead shots is equal to the volume of the water that flows out. Volume of all the spherical lead shots that are dropped into the cone. So volume of all the spherical lead shots is equal to the volume of the water that flows out of the cone. Is the equation relevant to the situation in words? Volume of all the spherical lead shots dropped into the cone, the volume of all those spheres is equal to the volume of the water that flows out of the cone. All right. Volume of all the spherical lead shots is equal to the volume of the water that flows out of the cone. Now, volume of one spherical lead shot, volume of one sphere is 4/3 pi r cube, 1. Now, volume of all the lead shots, how many we don't know. So let it be n. We'll assume that n lead shots are dropped into the cone. So you can just mention that here, let the number of lead shots dropped be n. You can just start like that. Let the number of lead shots dropped be n. And this is the equation in words. Now we are replacing them with the relevant formula. Volume of all the spherical lead shots. One lead shot, one spherical lead shot, 4/3 pi r cube. All into n. Like if 10 spheres are dropped into 10. 20 into 20. So, but we don't know here, right? We have to find that. So into n. Volume of one sphere into n will be the volume of all the spheres, all the n spheres, is equal to volume of the water that flows out. How much flows out? 2/5 of the water flows out. 2/5 flows out. So how do you find 2/5 of the volume? So whatever is the volume, 2/5 of the water flows out means 2/5 of the volume of the water flows out. See, 2/5 of the water flows out, meaning 2/5 of the volume of the water in the cone flows out. What is the volume of the water in the cone? It's equal to the volume of the cone. Because the cone is full of water. The water is filled up to the rim. So the volume of the water and the volume of the cone both are the same because the water is filled up to the rim. If the cone was partially filled with water, then the volume of the water will be less than the volume of the cone. But here it's filled to the rim, right? So the volume of the water, volume of the cone, both are the same. So 2/5 of that volume flows out. So volume of the water is the volume of the cone, which is 1/3 pi r square h. Just to differentiate, I'll use R1 here. Now this is the volume of the water, 1/3 pi R1 square h. This is the volume of the water. No, all the water doesn't come out. 2/5 of this comes out. So 2/5 into. 2/5 of this volume flows out. This is the volume of the water, which is the volume of the cone. All the water does not come out. Only 2/5 of this volume. So 2/5 into this. Of meaning into, right? Of stands for multiplication. So 2/5 of meaning multiplication of the water, meaning the volume of the water, which is 1/3 pi r square h. So 2/5 into 1/3 pi r1 square h. Okay. That's it. We constructed the equation using the formula. First using words, and then we replace the word phrases with the formula. Now we have it. So you see 3 on either sides. You can cancel out. Pi, you can cancel. And children, see, if you have written r cubed and r square here, you can't cancel r cubed and r square because the values are different. That's why you should differentiate. I've written r1 square and r cubed here. See, I've used r1 for the radius of the cone and r for the radius of the sphere. It's not like an algebra. If you have r cubed on one side and r square, you can cancel, no? It just becomes r. That's an algebra where, we don't have values attached to the variables. Here we have a value attached to this. This is the radius of the cone, and this is the radius of the sphere. They're not the same. They're different. We can see in the question. So you cannot cancel r cubed and r square. They have different values. So please differentiate. Don't write r square, write r1 square. Or use small r and capital R because they have different numerical values. So you cannot cancel r. So 3 and pi and now I think we have to substitute. So n we don't know, into 4 into r cubed. Radius of the sphere 0.25. 3 times 0.25 into 0.25 into 0.25 is equal to 2 by 5 into r1 square. So radius of the cone, where is it? 2.5. 2.5 into 2.5 into height of the cone, 11. That's it. You just have to solve this and find the value of n. So that you can take, if you want, you can take 0.25 as 25 by 100, which is 1 by 4. You can take 0.25. In the next step, you can write 0.25 as 1 by 4. Because 25 by 100, right? 25 by 100. So which is 1 by 4. Yeah. .25, please understand 0.25 is 25 by 100, which simplifies to 1 by 4. So you can write 1 by 4 is equal to 2 by 5 into 2.5. What's 2.5? 25 by 10. And what is 25 by 10? 5 by 2. 5 by 2. If you want to get rid of the decimal point, children, see, if you don't want the decimal point, you can do this. You don't have to show those steps. 2.5 is 5 by 2. You can straight away write that. So 4 and 4 gets cancelled. N is equal, and here also 5, 5, 2, 2. Okay, so n is equal to, in the numerator, we have 5 into 11. And from here, the 2 4s will go up to the numerator, 4 into 4, divided by 2. So 2 1s are, 2 2s are, 55 into 8. See if I'm right. 440. Yeah, 440. Completed, children?
Yes, ma'am.
Okay. Anybody is still writing, please let me know so that I'll wait. Okay. Yeah. Is your next question? A building is in the form of a cylindrical. No, not cylindrical. A building is in the form of a cylinder. A building is in the form of a cylinder surmounted by a hemispherical walled dome. Okay, so like this, in the form of a cylinder surmounted by a hemispherical walled dome. Surmounted by a hemispherical walled dome and contains 4119 by 21 meter cubed of air. So that is the volume of the air inside the building. So the building is cylindrical with a hemispherical ceiling. That's how we should understand this. The building is cylindrical with a hemispherical, ceiling. The ceiling is a dome. So it's hemispherical. And the volume of the air inside the building. The volume of the air in the building is the volume of the cylinder plus the volume of the hemisphere. The volume of the air in the building, because the building is the cylinder and the hemisphere put together. So the volume of the air in the building is the volume of the cylinder plus the volume of the hemisphere, which is 4119 by 21 meter cubed. If the internal diameter of the building, so which is the internal diameter of the building? The diameter of the building is the diameter of the hemisphere or the diameter of the cylinder. Both are the same. The diameter of the building is the diameter of the hemisphere or the diameter of the cylinder. Both are the same. Okay, so this diameter, so let's call it 2r. Okay, so the internal diameter is 2r. The internal diameter is 2r. Okay, now this is equal to the total height above the floor. Okay, so the height of the building, the total height of the building, height above the floor, meaning the height of the building. This is the floor. This is the floor. So the height above the floor. This is the height above the floor. This is from the floor. This is the floor. This is the ceiling. This height is equal to the diameter is what is given. The height of the building is equal to the diameter is what is given. Now, what is the height of the building? It is the height of cylinder plus height of hemisphere. And this is equal to 2r. I'll give you time to read it for yourself and understand better. So the internal diameter, which is 2r, is equal to the height of the building. And what makes the height of the building? Height of the cylinder and the height of the hemisphere together. So height of the cylinder plus the height of the hemisphere together is equal to 2r. But we know that the height of the hemisphere is r. Because for a hemisphere, the radius is equal to the height. In a hemisphere, height is equal to the radius. If the radius is r, the height is also r. So this is r. So height of cylinder plus r is equal to 2r. So height of cylinder is equal to 2r minus r, which is r. 2r minus r, which is r. Okay. Yeah, I'll work the answer. I'll show you the steps. Please write the question, and if you have any questions, you can ask me. Finish the answer, and you can ask me if you have any questions later. Yeah, please solve this and find the value of, when you solve, you'll get the value of R. And then you can find the height of the building, which is 2R. Yeah, I'll just come back in, say, about 5 minutes. Please complete the answer. So what is this as an improper fraction? Yeah, tell me the improper fraction.
880 by 21.
880 by 21.
Very good. Okay, 880 by 21. So is equal to 880 by 21. So after this, you can take out R is radius is the same. So you don't have to say R1, R2 because the radius is same for the cylinder and the hemisphere. So you can take out common pi R square common. You can take out pi R square common and you will have H plus pi R square, right? So you'll have H 2 by 3 R is equal to 880 by 21. So R is what we don't know. We don't know the value of R. So pi is 22 by 7 into R square. We don't know. H is 2R. We just not 2R, R. What is H here? It's the height of the cylinder. Because see here, H is here. H is from this one, height of the cylinder. H is not the height of the building. Where is H? H is the H is from the volume of the cylinder. Pi R square H, height of the cylinder. So height of the cylinder is here, R. So this one is R plus 2 by 3 R is equal to 880 by 21. So 22 by 7 comes to the other side as as 7 by 22. Reciprocal. Now R square here, 3 is the common denominator. So you have 3R plus 2R. And then 22 ones, 22 40 times, 7 ones are 7 threes are. So we have R square into 5R by 3. 5R by 3 is equal to, what do we have here? 40 by 3. 40 by 3. Now R square into R is R cubed is equal to, bring 5 by 3 to the other side. Bring 5 by 3 to the other side. So we have 40 by 3 there. 5 by 3 becomes 3 by 5 on the other side. Reciprocal. R square into R is R cubed. 40 by 3. 5 by 3 becomes 3 by 5. Reciprocal on the other side. So now 3, 3, 5 ones are, 5 eights are. So R cubed is equal to 2 cubed. R is equal to 2. The radius of the cylinder or the radius of the hemisphere is equal to 2 meters. 2 meters. Now the height of the building. We know that the height of the building is 2R. The height of the building is given is equal to the diameter. The height of the building is 2R. So therefore, the question is to find the height of the building. Therefore, height of building is equal to 2R, which is 2 into 2, 4 meters. 4 meters. Please complete. Finish writing?
Yes, ma'am.
Okay. Yeah, these three questions are no longer a part of your syllabus. 1, 2, and 3. So we'll try the fourth one. From a cuboidal solid metallic block of dimensions 15 centimeters by 10 centimeters by 5 centimeters, a cylindrical hole of diameter 7 centimeters is drilled out. It's removed. It's drilled out. Find the surface area of the remaining block. Find the surface area of the remaining block. Yeah, please try that. I'll just give you some 3 minutes time. Tell me the, tell me in words as to how you will find the surface area of the remaining block. That is, you don't have to tell me the formula. Just tell me in words. How you would find the surface area of the remaining block? Yeah. Yeah, tell me. So how will we find the surface area of the remaining block? Okay, let me begin. So it is the TSA of the cuboid minus what? TSA, the total surface area of the cuboid minus, continue. TSA of the cuboid minus the area of two circles minus area of the two circles. Because when you find the total surface area of the cuboid, you're finding the area of this rectangle completely on the top. But because the cylinder is drilled out, there is a circular portion on the top which is empty. There is no material there because the cylinder is removed, no? So this circular portion on the top has no area. It's empty. But you have found the TSA of the cuboid, which includes this area. Again, the TSA of the cuboid includes this area also, but there is no material here. There is no material here on the top because of the cylinder which is being removed. So it's the total surface area of the cuboid minus the area of the two circles. Continue. Then what? One more thing. See, I don't know how to take. Yeah, I don't know how to take it. Is it that you're not following or you're just hesitant to unmute and share your thoughts? I don't know, but you can just say whatever you feel. We learn by, you can be right also. You don't have to assume that you may be wrong and keep quiet. Yes, somebody wanted to say something.
The CSA of cylinder.
CSA of cylinder, correct. Plus or minus?
Plus the CSA of cylinder, ma'am.
Plus the CSA of the cylinder, correct. Plus CSA of cylinder. The surface area of the remaining block will be, see, we have understood this. Surface area does not work like this. It is not TSA of the cuboid minus TSA of the cylinder. It does not work like that. That's how volume works. If we have to find the volume of the remaining block, if we have to find the volume of the remaining block, yes, then it is the volume of the cuboid minus volume of the cylinder. Volume is always like that. The total volume minus the volume of whatever is being removed. So volume of the cuboid minus the volume of the cylinder will be the volume of the remaining block. Volume works like that, but not surface area. Surface area, you should take away, you should write one formula, and from that you should remove what is not there and add whatever is new. So in this case, we start with TSA of cylinder. TSA of cylinder, we start with this. Now in this area, what is not, we see, now when you find the total surface area of the, not cylinder, sorry, TSA of the cuboid. When you find the TSA of the cuboid, you've included some area which is actually not there now. When you find the TSA of the cuboid, you have included some area which is actually not there now. And they are the areas of the two circles. They are the areas of the two circles. So take it away because it's included in TSA. So you start with TSA of the cuboid, take away whatever is not there now. So TSA includes the area of the two circles, but it's not there. So take away the area of the two circles minus area of two circles. And because the cylinder is drilled out, cylindrical hole, the curved surface area is being created there. So plus, if new area is created, add plus CSA of cylinder. Yeah, please work. So, okay, so see here in my, the working here, you know, I've still elaborated that. So here you can see I found only the CSA of the cuboid. CSA of the cuboid, that is the area of only the four walls. Now, this is the area of the top, LB. But what is not there? Pi r square is not there. So take it away. Then what is this? The area of the bottom. But what's not there? Area of the circle. Take it away. Then add the CSA of the cylinder. The surface area of the remaining block is equal to CSA of the cuboid plus area of the base minus area of the circle, area of the top minus area of the circle, plus the CSA of the cylinder. You can do it like this also. What we discussed earlier, CSA of cuboid minus area of two circles plus CSA of cylinder. Both are the same. What you see here and this one, both are the same. Will give you the same answer. Yeah, please complete this. Just come back in 5 minutes, children. Please complete this. Finish working, children?
Yes, ma'am.
Okay.
Yes, ma'am. Ma'am,
Yeah.
ma'am, can we also subtract the curved surface area of cylinder from the total curved surface area of cuboid and then get the answer?
Subtract the curved surface area of the cube cylinder from what?
From the CSA of the cuboid, ma'am.
Okay, so see, CSA of the cuboid includes, you can subtract only if something includes that area. So now when you find the curved surface area of the cuboid, it is about the area of these four walls. The area of the four walls, the area of the four outer walls of the cuboid does not include the CSA of the cylinder. It's not volume. It's not about the material inside. It's only about the outside surfaces. So when you find the curved surface area of the cuboid, it's about the area of these four flat things. Now, does that area include the CSA of the cylinder? No, then you cannot subtract. See, you can subtract only if that area includes it. Like, for example, when you find the area of the base. See here, when you find the area of the base of the cuboid, when you find the area of the base, you're finding the area of this whole thing. L into B, you're finding the area of this whole thing. But the circle area is missing. So because L into B includes the area of the circle, you're taking it away because it's not there now. Similarly with the top, when you find the area of the top, L into B, it's a rectangle, right? The top is a rectangle. And when you find the area of the rectangle, it's the area of this full surface, which includes the area of the circle. But no, the circle is not there. Meaning the circular portion is empty. There is no material there. So since L into B includes the area, meaning L into B is this full area, but the circular area is missing. So we subtract. Because this area includes this area. Yeah.
So can we subtract like the CSA of cylinder from the TSA of cuboid?
The TSA of the cuboid does not include the surfaces which make the total surface area of the cuboid does not include the curved surface area of the cylinder. The curved surface area of the cylinder is a different area. The total surface area of the cuboid, that is the 6 faces, they are different from the 6 faces of the cuboid. Those regions, those surfaces are completely different from the surface which makes the curved surface area of the cylinder. So there is no connection at all between the two. You cannot subtract. When the first thing includes the second area, then you can subtract. You write one thing first. If that one includes some area, that can be subtracted. Now, when you find the TSA of the cuboid, which is about the area of the 6 flat surfaces, those surfaces have nothing to do with the, the curved surface area of the cylinder. The CSA of the cylinder is not a part of the total surface area of the cuboid. So they're not connected at all. The surfaces are not, there is no surface common. Yeah, let me put it that way. There is no surface common between the, the total surface area of the cuboid and the curved surface area of the cylinder. There is nothing common. The surfaces are completely different. So we can't subtract.
Yes, ma'am.
Yeah, there's nothing common. The total surface area of the cuboid, that is the 6 surfaces, they are entirely different from the surface area of the cylinder. There is no surface common. So you cannot subtract.
Yes, ma'am.
Okay. Because you'll have to cancel here 7 and 7, 2, 11, all this. And then 77 by 2 is 38.5. 7, 7, 2, 1s are 2, 11s are. 11 into 7 is 77 by 2 is 38.5. Yeah. So here a cylindrical road roller made of iron is 1 meter long. So that's the height. See, we say when a cylinder is, a log of wood, say a log of wood. When you place it horizontally on the floor like this, you will say length of the wood. Length. When the same thing is placed vertically, then we say height. The cylinder, if it is placed horizontally on the ground, then we say length of the cylinder, which is nothing but the height of the cylinder. But if it's vertical, if it's placed vertically like this, then we say height. So we say length if it is horizontal, we say height when it's vertical. Both are the same. Length, height, both are the same. Length of the wood. Because it's horizontal, we don't say height here. But if it's vertical, we say height. That's all. So a cylindrical road roller made of iron is 1 meter long. 1 meter long meaning the height. The height of the road roller is 1 meter. Its internal diameter is 54 centimeters. And the thickness of the iron sheet used in making the roller is 9 centimeters. So this is a cylindrical shell or a hollow cylinder, because you can see the wall is thick. There are two radii here. One internal radius and one external radius. Internal diameter is given 54 centimeters. So the internal radius is 27 centimeters. And the thickness of the iron sheet is 9 centimeters. So using that, you can find the the external diameter or the external radius. Find the mass of the roller if 1 centimeter cubed of iron has 7.8 gram mass. Take pi as 3.14. This is actually a simple question for you for 10th standard, because it's actually from 9th standard, which can be asked. Yeah. So how do we do this? Yeah. What is the formula to find the volume of the cylindrical road roller? Tell me the formula to find the volume of the cylindrical road roller. See the road roller, it's hollow, it's empty here. This is empty. This is empty. You can see through. You can see through. Like the roll of a sellotape. Okay, exactly like that. The road roller, it's heavier, that's all. You can lift the roll of a sellotape while you cannot lift the road roller. So exactly like the sellotape, you can see through. Exactly that. You roll a sellotape, that roll on the top of your table or any surface. That's the road roller. So it's empty here. You can see through. So from here to this part is the inner radius. And from here to here is the outer radius. From the center to the inner wall. This is the thickness of the wall. This is the thickness. This is the thickness of the wall. This is the wall. From here to here is the wall. Okay. This is the wall. It's uniformly thick. So from here to this inner wall is the inner radius. And from here to the outer wall is the outer radius. Small r, capital R. From the center to the inner wall. From the center to the inner wall is the inner radius. From the same center to the outer wall is the outer radius. And this is the thickness. This is the thickness. It's uniformly thick. So the internal diameter is 54. So the internal radius is 27 centimeters. Okay, so this is 27. Which one? From here to here, this is 27. And the thickness of the iron sheet used in making the roller is 9. So this thickness, this one is 9. This one is 9. So the outer radius is equal to the inner radius 27 plus the thickness 9, which is 36 centimeters. 36 centimeters. The inner radius plus the thickness is the outer radius. So we know now small r is 27, capital R is 36, and the height of the cylinder is 1 meter or 100 centimeters. So we know everything about the cylinder. Inner radius 27, outer radius 36, and the height of the cylinder or the length of the cylinder 100 centimeters, 1 meter, 100 centimeters. You should have all the values in the same unit. So we have it all. Now find the volume of the road roller. Volume is given by the formula pi h into capital R square minus small r square. I told you, yeah, that question about a hollow sphere. Okay, I told you when a solid sphere is empty in the middle and the wall is thick. The question we had come across earlier about a sphere which is empty in the middle, but the wall is thick, is a spherical shell. It's called a spherical shell or a hollow sphere, which has two radius from the center to the inner wall, center to the outer wall. So how do we find the volume there? External volume minus internal volume. Same thing here. The cylinder, you can see through from the middle. It's empty. So from the center, inner wall, inner radius. Same center, outer wall, outer radius. Because the wall is thick, it's given. The wall is thick. The material which is used to make the roller is thicker. So here also volume is external volume minus internal volume. External volume, that is pi capital R square h minus internal volume, pi small r square h. External volume minus internal volume. Both are cylinders. Height will be the same, h. Internal height, external height, both are the same. Internal height, external height, both are the same. The radius is different. Internal radius is different from the external radius. So the volume of the roller is equal to external volume minus internal volume. So when you take out common, you get pi h capital R square minus small r square. This is the formula. So once you find the volume, multiply by 7.8 to get the mass of the roller. Find the volume, 1 centimeter cube. That volume has a mass of 7.8 grams. So you should find how many centimeter cube. So you must find how many centimeter cube, sorry, of iron is in this roller. How many centimeter cubed in this roller? 1 centimeter cubed, 7.8 grams. So in this one, how many centimeter cubed? So find the volume into 7.8 will give you the mass of this roller. Yeah. Please work. Finished? Okay. Why, Hasif, you also have mic issues? Finish working? See, when I say small d, it is the, when I say small d, it is the internal diameter. Capital D, external diameter. Small r, inner radius. Capital R, outer radius. See here, small d, that is the inner diameter, 54. So inner radius, 27. W is the thickness. W means thickness, 9 centimeters. So capital R, the outer radius is the inner radius. That's the thickness. 27 plus 9, 36. Volume, this is the formula. Substitute. Multiply by 7.8. You get so many grams. Convert that to kilograms by dividing by 1000. So many kilograms. Okay. Done, all of you?
Yes, ma'am.
Okay. Yeah, we'll wind up the session with this one. We'll do this and wind up the session for today. So here, a mason constructs a wall of dimensions, all this, with bricks, each of size given here, and about 1/8 space is covered by mortar. So mortar is the mixture of cement, sand, and the stones called the gravel. So that mixture, cement, sand, and gravel all together make the mortar. Yeah, no, when you arrange the bricks, they don't make the wall. You have to bind the bricks together, right? You arrange the bricks. When you arrange the bricks, they don't make the wall because you can easily push the bricks and like break down the wall. So if the bricks have to be intact, you have to bind them. So that's done using the mortar, which is a mixture of cement, sand, and gravel. So when we say volume of the wall, it is not the volume of the bricks alone. Volume of the wall is not only the volume of the bricks. Volume of the wall is the volume of the bricks and the volume of the mortar. Volume of the bricks plus the volume of the mortar, because these two make the wall. These two make the wall. So volume of the wall is equal to volume of the bricks plus the volume of the mortar. Mortar is used to bind the bricks together. Bind the bricks together so that it's a wall, a strong wall. So a mason constructs a wall, dimensions given to you with bricks, again the size of the bricks given to you, and about 1/8 space is covered by mortar. So of the wall, 1/8 is covered by the mortar. So how much is covered by the bricks? 7/8, because the total is 1. But when we talk in fractions, the total is 1. So out of 1/8 is the space used by the mortar. So the remaining 1 minus 1/8, 7/8 is a space occupied by the bricks. So the space occupied by all the bricks is 7/8 of the volume of the wall. See here, 1/8 of the volume of the wall, is occupied by mortar. So 1 minus 1/8, which is 7/8 of the volume of the wall. 7/8 of the volume of the wall is occupied by the bricks, by all the bricks, all the bricks. So what is the volume of all the bricks? Volume of all the bricks is equal to 7/8 of the volume of the wall. This is the equation of the volume of the wall. This is the equation. See here, listen to this. Volume of the mortar is equal to 1/8 into volume of the wall. See, volume of the wall is the total thing. Volume of the wall is the total thing. 1/8 into the volume of the wall is the volume of the mortar. 7/8 into the volume of the wall is the volume of all the bricks. That's all. It's like a class, and if 1/8 of the class are boys, then 7/8 of the class are girls. 1/8 of the class. Number of boys is equal to, what do we say? Number of boys number of boys is equal to 1 by 8 of the class, of the number of students in the class. Number of students in the class. Similarly, number of girls is equal to 7 by 8 of the number of students in the class. In the same way, volume of mortar is equal to 1 by 8 of the volume of the wall. And volume of all the bricks is equal to 7 by 8. 1 minus 1 by 8. 7 by 8 of the volume of the wall. So off means into volume of the wall. So this is the equation we will go ahead with. Volume of all the bricks is equal to 7 by 8 into volume of the wall. And how do you find volume of all the bricks? It is n into volume of one brick. N into volume of one brick. The equation we'll be going ahead with is volume of all the bricks is equal to 7 by 8 into volume of the wall. Volume of all the bricks is n into volume of one brick. And what's the volume of one brick? Brick cuboid L into B into H. So 22.5 into 11.25 into 8.75. L into B into H. L into B into H is the volume of one brick into N. We don't know how many bricks, so into N will be the volume of all the bricks is equal to 7 by 8 into volume of the wall, which is again a cuboid. Both the wall and the brick are cuboids. So in both the cases, the formula to find the volume is LBH. You can use small LBH for the brick and capital. You can see it in my slide here, I think. Have I? Okay. If at all you're finding separately, you can use small LBH for what's that? Brick, and capital LBH for wall. So 7 by 8 into volume of wall. What's the volume of the wall? L into B into H. Because again, it's a cuboid. And there you have L is 270, B is 300, H is 350. That's it. This is the equation. You can convert these to fractions if you want. 225 by 10, 1125 by 100, 875 by 100. You can convert it to fractions. You can remove the decimal point by converting the numbers to fractions. That's it. Now, see, n is the only unknown. In this equation, n is the only unknown. All are numbers. N is the only unknown. So solve this equation and find the value of n. That's all it is. Again, this is a 9th standard question. Yeah, since it's time, children, take a screenshot and complete this by the next class. Take a picture. Done?
Yes, ma'am.
All right. All right, children. So that's it for today's session. Thank you so much. You may all leave the call. Good night.
Thank you, ma'am.
Thank you.
Thank you, children.
Thank you.
Thank you, children. Good night.